All right. We're live for Advent Code Day 15 of 2024. About a little over 30 minutes ago. But what I wanted to do today to warm up is go over day 14 and try some variations out. What I really like about this problem is that there are many different approaches to finding this. Um, yeah, and just to recap my approach, I scrolled through the first 100 images. And I found one at frame 65 that was interesting. It started lining up horizontally. So you're starting to see like the top and bottom boundaries of this image. And then I iterated 103 at a time so that the vertical would cycle because I figured that that looked close to correct for at least a vertical component of these bits. And I think I did find what ended up being my answer because we had 65 plus 74 times 103, 7687. So at that point, I'd already found my answer. And I was doing something wrong when I was printing it, because when I was printing it, I wasn't seeing, I must have been getting the wrong index. But my final answer by the end of the night was that 7687. Let's see, there's a lot of code here. A lot of this was exploratory, digging into the data. But I think what I'd like to do is just start off a file, day 14, we'll call it variance. Okay. I don't know, we'll keep most of that. And I did want to change a little bit of my approach. So this move takes an area argument. I want to give it a number of times argument of sorts. Um, I might not even want it to be a method. So we have our boundary area that we keep. You don't need this comment. Our parsing code's fine. Yeah, so my approach to getting to some position was to repeatedly iterate with my move method, which adds the velocity to the point. But we can just multiply the velocity by the number of times we're moving, and that should be more direct. I think I'll just kind of keep the area as a global. Just define it at the top here. We could always make it implicit or something if we need to. So we can move some number of times. And I don't know, we can move at most 101 by 103 times before it starts looping, yeah? In fact, this is one such that this 10,000, I missed early on that this is the upper bound. I think I thought it was the upper bound and I convinced myself that was not, but 101 times 103 is the upper bound in your search space. So you could just actually generate all of them. Efficiency doesn't really matter here anywhere. We're still going to take this. We're going to do robot and we wrap around with wrap around the point p plus v times n within the area. I think I'm just going to define my wrap method here in terms of the area. Okay. This could actually be problematic if these are negative, because modulo doesn't work the way I want to with negative bits. So I will test that. To do test negative. But yeah, I don't really want to use the area here. Just call it our main area, that width and height. We're not really testing with other areas, so global it is. Now our new final positions for part 1 is just robots map move 100, and we get the positions, and then we don't need the size. Okay, this must have just been test code. I'm happy with how these quadrants are defined. Okay, let's check that against our day 14. Hold on, is this running? All right, this has been a recurring issue. My point class doesn't seem to update. This is AOC.point. It does in fact define that. Let me see. Well, we're able to use this plus, right? This plus is defined right next to it. Okay, I'll just recompile the workspace and see if that fixes issues. So we know this. The vertical positions repeat every 103. Yes. The horizontal positions repeat every 101. So once we found out 65, we can in fact repeat every 101 until we find it. And that was a gist of our first approach. And you know what? That approach works. I did find the correct number. I just never plugged it in. I think I found it like 2 hours before I ended the stream. Is this compiling it? We'll get that a second. So I do want to try that again. Let's try this. So let's define a separate show method. Def show image. Oh. So I'll do a state, which is a list of robots. And we'll just print from area.draw, given some point. And I don't know if we want to do it. It's just 100. I'll still make the hash map. Just call it P's. Okay, so if P's contains, rather, if P's contains P, that else that. Okay, so we have state 65, and we don't need to iterate. We can just take our robots, map, move 65, and we'll comment on here. This was correct vertical state found visually. Right, and then now we can iterate from there. So we start from state 65, and what do we do with it? We move 103 at a time, or width. No, not one. Is it? Yeah, 103 at a time, maintaining the vertical state. So we would do robot or our state dot map dot move and area dot height. Right. So how possible possible solutions. Sure. So we can iterate that way, and then we're going to take area.width, because after 101, they start repeating. Okay, let's do it this way. And then now let's just print all of those. So this is recreating my first solution. So possible solutions dot, I guess for each, let's zip with an index dot zip index. And for each state and index, well, we say seconds passed. And we're going to do 65 plus area dot height times I, right? And then we show an image, and then we just print another line. Okay. Let me just get this compiling. What's going on here? Drop point intrinsic. This is a weird syntax error, or a weird error message rather. I don't think it's actually related to that right there. I think it must come from somewhere else. Yes. So that's actually happened because a then is missing here, right? I'm gonna place some marker there because I think that should go back to the compiler team. Bad error message. For syntax error. Because I've seen that come up before. This is with the new Scala 3 indentation syntax. Generally, the error messages have improved a lot, the compiler messages. But that right there is a weird one. Wait, move is not a member of area. State 65. This is getting none. We map H to a move. Oh, is move not defined yet? Mapping on any. What is this? A list of nothing. So we iterate starting with state 65. This is a list of nothing somehow. I mean, this should be a new robot, absolutely. Okay, so we just copy this robot and update the P by wrapping it. Although I wonder if, that's fine up there. I wonder if that should be defined on the points. Okay. That is now a list of robots. Good. And I know this should be printing now. Maybe 14 variants not found AOC. We can't import from AOC. Okay, so this is a good thing to fix before tonight's problem drops because we're having some weird build issues. I don't know. Metals, maybe I re-import to build. Or is it not compiling? Is point.scala not compiling? Let's open up our point tests worksheet. 0.34 times 2. I guess we're still compiling. Alrighty. Maybe just restarting VS Code will help here. If not, maybe I'll check the build. There shouldn't be anything wrong with the build file. Like this is working yesterday, the day before. All right, this should compile. And in the meantime, let's talk about other approaches that people took. So this here is the visual approach where we scan 100, then use that to generate another 100, which are multiples of 103, and you scan those as well and just pick one. So pretty fast if you just do it right the first time, which apparently I had some sort of mistake. We'll see if this works again this time around. Otherwise, we can find a border. This is what I ended up going with. This is what I pivoted to. Here, you have a list of approaches. So you can find a border. We could seek a state with many connected components. Okay. Yeah, you could find this. You could actually find this programmatically by looking at density. Using density heuristic, right? But I mean, that's if you knew what you were looking for. Same with the border. The border is like if you knew what you were looking for, and you kind of figure out what you're looking for by looking at the images. So finding the many connected components, well, let's see, requires knowing that it has a border, or let's say guessing, right? Because that really was a blind guess in the dark. Um, so find solid area, and also it also requires guessing. Um, yeah, this requires less guessing because it still works even if it has holes. So this works with holes or off center. I guess there's a symmetry approach. Technically works, but image not centered. So it is symmetric, but it's not centered. Let's say image is technically symmetric, but not centered. Requires guessing. I think of these, I do want to do the connected components. We can do that pretty quickly. But also, I just want to figure out what's going on here with my build. Are there any useful messages? Um, okay, let's pull up SBT and make sure the project is compiling in here. There must be like some... Yeah, okay, their file is not compiling. That's preventing this. It looks like day 11 existing and also the interval file existing. What theme am I using? Let me check. I think it's color theme. Outrun Night meets Synthwave. So I use one of these two for admin code. Because it matches the admin code theme. Yeah, kind of similar, right? Like this has, the greens and the yellows. The comments when this is working, and the comments are showing up to the side with the values, then it should be green. It's not my yearly color theme, but I do like it for AOC. Okay. Yeah, so we're just not compiling. Let's look at interval. This file doesn't compile. Yeah, because I was like halfway through implementing it. Oh, that's right. When I started the stream last night, I was halfway through implementing this. Okay. Let's see if things compile now. There's also day 11. Okay, something weird happened day 11. I don't think I even want this code, right? Um, okay. What else do we have? Um, interval dot Scala still has more errors. All right, you know what? Let's just comment this whole file until we're ready to work on it again. We can leave the trait and we'll just comment both the implementations. Okay, anything else? We might not actually have time to go over variants of day 14. But there we go. We are working again. That's good. We want to have that running for day 15. All right, so this is basically a refactor of my first approach, the one I've been in favor of searching for the border yesterday. And it should work. Let's see. So we'll copy this worksheet output. Hey, arrow bounce. Welcome, welcome. I can't remember if you, I can't remember what your approach was. Did you tell me yesterday? Let's see. Mode. Wait. Gen X guy. My favorite coding language? I mean, I suppose it would be Scala. Like, there are a lot of other things that are fun or have like really cool ideas. Like, I want to play more with Idris and Unison. I want to play a bit with Rust. But Scala is what I use the most. And, you know, it has its warts, but every language has its warts. It's the language I hate least. We could say it that way. You printed all 10,000 iterations and Control F. Ah, that's great. That's great. Good way to do it. So right now I'm retrying my very first approach that I tried last night, right? Which was I looked over the first 100 images. I found one that's interesting. And I figured, okay, the vertical locations of the robots are good. Let's iterate it until the horizontal locations are good. So I iterate from there 103 at a time. And since there's a limit of 101, wait. Where is that? Yeah, so we start from that state 65, the interesting one I found, and we take at most 101. So I only have 100 images to scroll through. So you could solve it by scrolling through images twice, through 100 images twice, instead of scrolling through all 10,000. But I didn't see it last night. Or I did see it, right? You remember me playing with this number here? Because this is the one I found was interesting. So the 74th state here was interesting. And I started using that number. That was the answer the whole time. So I had to answer like a couple hours before I submitted it. Oh, hey, Michael. You got it. You got it. Great. You did a BFS for a group of 4 directionally connected dots. Okay, great. Great. Yeah, so I mean, I like all the approaches. I really like the connected components because it works with the least amount of knowledge about what the image is supposed to look like. I mean, I do. In theory, I like the density approach. Well, the density approach requires you knowing where the image is going to be. I didn't think to look like in the center and make sure it has the highest density. Okay, keep scrolling. It should just really show up. It's obvious, right? But yeah, like you could try searching for just a random solid air. Like the image might have holes, so you could look for the shape, or you could look for like a block of 9 connected dots or something. But that only works if it's solid, right? Like it could have had holes in it. So here, Okay, interesting, interesting. So this is it. This is the one I thought was interesting. State 7687, but this is the image I was seeing yesterday that was almost the tree and not it. But this is it. This is the correct index. So am I printing something wrong here? Do you remember this image yesterday? I rewrote how I move points around. So I don't iterate anymore. I just multiply the velocity and calculate that state directly without, any reference to a previous state. Okay, let's see if we can figure out why. Um, that was it. This was it the whole time. Like, this number's correct. This image is wrong, but I did find it. And I started playing with this number, and I started trying to iterate from this number to find one that was more accurate. Okay, so we take robots, we map move 65, possible iterations, possible. We move it 65 times, and then we move it area.height 103 times. And the 74th state should be this one, 7687. Okay, let's remove this for just a second. And let's take the final state. I don't know, robots.map, and we're going to move him 7687. 7687 times. Dot move. And we're just going to show that one. Show image. Okay. Whoops. Copy worksheet output. I don't know, man. Okay. When in our original day 14, when we printed, where is it? Scratch 2, I think. Well, what happened here? I think it's at the bottom. Here, right? We get that one. And that one is end state being 7687. And hold up. Day 14. So when I was working on this, oh, on day 14. Day 14, worksheet 2024. End state, end index. And the end index is what? 2-minute warning, by the way. Yeah, it looks like you've lost some bots. You're right. Okay, sir, there it is, 7687. So it must be, I don't know. It must be an issue with my move function, except that this is the same move function, and it prints the image properly. So I don't know what to say. Okay. 1 minute and 37 left. Yeah, that is interesting. Both pieces of code think that this is state 7687. But this one, we just find it. We don't like calculate it from the index. Maybe it's like an off by 1 or 2 or something. Okay. Well, we can do that later. For now, let's do a day 15 worksheet. Oh boy, we are right. Good luck, everyone. Good luck. Good luck. So this is now our day 15. Okay. And warehouse woes. So is this our input? And we have a bunch of directions that I guess a character is moving to try and get to that goal. And it's a lanternfish again from 2021 day 6. They have a map of your warehouse and list of movements the robot will attempt to make. Problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. Okay. If there are any boxes in the way, the robot will also attempt to push those boxes. However, if this action would cause the robot or box to move into a wall, nothing moves. Okay, we can do this. Initial position is that these are shown, and the rest describes the moves. Straightforward. Now, what's the question? Oh, right. This is what it ends up looking like by the end. Lanternfish use their own custom positioning service. Cool. To track locations of the boxes. 100 times its distance from the top edge. Oh, okay, this is just how we compute the answer. So we want the GPS of all the boxes at the end. Sum of all the boxes' GPS coordinates. Yep, right there. After the robot finishes moving. Okay, this is very easy, very easy. To vector, and we'll call this the grid. Area around that grid, yeah. And let's just take a look at our input. Okay, so there are walls inside of there. And let's just parse each of those out. So val start equals area, that points iterator, grid equals an at. And we're gonna make that a find. Okay. Now we have the boxes. Almost. This is an O. And then val walls. Okay. And we have a state that we keep iterating on. So that move, we have, let's see, our location. So position, walls. This is at point. And boxes. And then a direction. And what do we do here? We have a next set of states. In fact, we can kind of just go straight to like a. So that is our initial state. So we have start, boxes, walls. Oh, we're going to mix up boxes and walls, aren't we? Those don't need to be separate sets. It could be a map actually. I don't know. We could call it contents. So this is a map from point. Yeah, occupied. If something's occupied, maybe. I don't think so. Point to car. We'll consider doing that later. Anyway, we have this. It's working. So we have position, boxes, and walls. The new position. So if what's ahead, oh, and then we have a direction. Oh, hold on. This is not a fold left. This is or an iterate. This is a scan left or fold left rather. So val movements is going to be a list of directions. We can parse that later. Oh, the input's not a grid. So we can figure that out. Movements dot fold left. And here's our start state. We have pause, boxes, and walls. And if pause dot move in the direction. Oh, hold on. This is tupled with the direction. Is empty. I guess this is where it'd be nice to have a map. So we could just do this in one go. Okay, so we're going to take I don't know, let's do it this way. For x in area.x range, y in area.y range, and p equals that point xy, and then p to grid p if. So if it's not floor, yes, exactly that. And we'll call this initial. Let's just call this a state, actually. So we'll call this a start state. So we only pass in and the start position, I guess. Am I going to regret this? I'm going to regret the silly refactor, aren't I? Okay, so if not start state, or rather, let's say start state at that position. We'll call that the target. So val target, or next pause is this. So if next pause is empty, then our next state is simply, I know we add in start, no, next pause and we just give in the same state. All right. Else, if it's a wall, then we know we can just stay still. Uh, so if that contains a wall, then we just return the same pause and state. Otherwise, we have to check for box movements. And we can do a search function. And do like all the boxes move? Can the robot push multiple boxes at once? Um, let's see, push. If there are any boxes in the way, the robot will attempt to push that boxes to move. That would cause the robot or a box to move into the wall. Nothing moves instead, including the robot. I'm taking this to mean multiple boxes, right? Can we see an example here? Yeah, okay, multiple boxes. So let's see. Def boxes. Other side of boxes. Other side boxes. So this is going to return a point. So we start from position and then the state map from point to character. And then we go with what else do we need? No, I think that's good. So let's just do a function that gets the point that's on the other side, and we check what that is. So we're going to iterate from this point. Iterator dot iterate, starting on pause, and then we have a direction that we're moving. Okay, so pause, dir, and state. So we move in that direction. And I guess we could do a drop while. So we're going to drop the first one because that's our starting position. And then drop while it's a box. A box is an O. Okay, and then we take next. Oh, and of course we should also we should make sure that these are all in bounds. So this is an option. No, this is fine. We can do that. We can do that later. This can just be a point, and it'll be the caller's job to make sure the other side is in bounds. Okay, if it's empty, we're good. If it's wall, otherwise it's a box. Val, far side. Oh, I like far side better than other side. Okay, if it's in bounds, area that contains far side. Well, actually, let's do this. If state of the far side it should not be a box, but if it's a wall, then we just keep the position and state. Else if I mean it's either a wall or it's nothing really. It's floor or it's empty. Yeah, and it's bordered with walls. We only need to do an inbounds check. Okay, so otherwise we do take next pause, and then we take our state, we update our state here shouldn't contain our character. Okay, the state is just the boxes and the walls. I think I preferred my first approach of having a separate set for boxes and walls. So next pause should just be empty. So we're going to be, no, next state is not empty. Well, yeah, I guess it is empty because we're removing that box and we're putting on the far side. So the far sides have a box, but we're going to remove delete. Hold on, state here is a map, right? Let me make sure we've got this right. Okay, let's make sure it's compiling again. Oh, right, we need a case. Okay, syntax error. Movements. Oh, we've dropped movements. Val movements is a list of direction. Haven't parsed it yet. Great, now we can do this. So state dot minus. I want to use a name for that. What's it called? Removed. Yeah. So state dot removed next pause and updated. We don't want to update next pause. We just want to update the far side of the box. Okay, so that should do it. That should do it. And this is what val final. This is a tuple. So final pause and final state is that. And the answer would be the GPS coordinates of all the boxes. Okay. I still want to refactor this. I want to go back to the, we are going to go back. We're not going to use start state. No, not yet. Let's at least parse this properly. So we have our input. It's just going to be like all the lines to list. Grid equals input take while non-empty. And then we're just going to be like to vector. So that should work. And then the movements. So we can input dot drop grid dot height +1 because there's an empty line. And I think it's just one after that. And we're gonna, so that's gonna be a line. And we can just map on that. So case that equals dir.north. And Copilot can autocomplete this. There we go. Okay, let's see if everything's parsing correctly. I'm going to go ahead and just delete this. we only care about the wall's location. Yeah. So walls, this is going to be a set point. We don't really care about characters. So drop while walls. Oh, I like writing that better. So here we instead write if no walls and if not walls. Here. We just have to do, let's always do boxes before walls. Boxes and then walls. If not boxes, next pause. Or we could say, if not boxes or walls, then we do that. And otherwise, if walls, our next pause. There we go. No, we passed some boxes here. Yeesh. That's gonna get me in trouble. Okay, so next pause is boxes dot removed. Next pause, and then I know let's write this way. So boxes include. Oh, it's not compiling again, I think. So we're not getting good help. So boxes minus next pause plus far side. Oh, hold on. What even is this code? Yeah, okay, far side. So boxes minus next pause plus far side. And val ends equals I guess final walls or final boxes. And I guess we don't need to pass in walls every time. So we can remove that because walls don't move. So we have our start pause and then we have our boxes. Final boxes. There we go. Final boxes dot to list dot map. Let's see. It's the x coordinate times 100. Plus the y. No. The distance. Wait. Distance of top edge. 100 times its distance from the top edge of the map. Plus the distance from the left edge. What counts as the edge? This process does not stop at wall tiles. Measure all the way to the edge of the map. 100 times the top edge. So 100 times y plus its distance from the left edge, which is just going to be x. And the sum of all of those, I suppose. Okay. Now, barring any compilation errors, this should be it. Do we have errors? It doesn't seem to be speaking to me. Okay, here. Height is not a member of, let's say area.height. Area.height. And this, okay, we want just the last line. So we'll say input.last. right? It is a single line. This no, there are multiple sets of directions. Oh, okay. So I guess we map. Um, we get a line and then line.map. And I guess this is a flat map now. Okay, and the next pause to, I guess, boxes. Things don't move. This is the only case where boxes change, right? State is also boxes. Um, if far side is a wall, so walls, far side, there we go. No. Yeah, if the far side is a wall, then we don't do anything. Cool. And we have an issue here. Oh, we need more parents. Okay. Okay. 1509074. Sweet. I think I meandered slightly, but at least we got it really without any bugs, right? That always feels good to just do it without bugs. Um, hmm. Okay. Just as they start preparing for start coming, that a second warehouse robot is also malfunctioning. Okay, it's similar. The robot is twice as wide. The robot's list of movements doesn't change. Okay, so there's a new map. So it moves left and right at half the speed. Oh, I can be tricky about this, I think. Yeah, I think I can be tricky about this, like just multiplying positions by 2. I'll take a quick bathroom break, but I'll solve it by the time I get back. Okay, so we do the same thing, but we have a new start and we have new boxes. Yeah, we're just gonna copy it over. Well, walls 2. Oh, wait. A single box is still twice as wide. Let's think about. Hold on. Is a robot twice as wide? Everything except the robot is twice as wide. We can just give the robot like half points. They can push two other boxes at once. Okay. Interesting. Right, so they can be half aligned, so you can push multiple. So searching for the far side is different. Ah, okay, so we like DFS for a wall that's blocking any pushing, right? Hmm. Okay, it's not that there are twice as many boxes. uh, right, just twice as wide. Okay, now how do coordinates work in this version? I mean, I guess it's still, do you take the left side of the box? Or do you larger boxes? From the edge of the map closest to the closest edge of the box in question. Okay, so this is 0, 1, 2, 3, 4, 5. Okay. So I think I still want to note them by their left side. We just have to note that now that they're supposed to be twice as wide. Um, we could have a second set of the right side of the boxes. I don't know if I like that. Um, because if we're going just with one set of points for the box locations, then pushing them, well, checking if a spot is occupied by them, I guess we have to check a spot and check to its left as well. I do kind of like that. Just check a spot, check to its left. Okay, so we have val start 2 is going to be just multiply by 2. Multiply the x by 2, right? Start 1, start.copy x equals start.x times 2. Same thing here for boxes 2 and for walls 2. Okay, the list of movements is the same. Let's just take our code and modify it. New pixel perfect is following. Thank you, welcome. Movements is the same. And we can start with start 2 and boxes 2. I'm going to forget to change it to somewhere here. Note to self, debug, check for 2. This makes me want to use vars. Okay, but I'm supposed to be shadowing anyway. So pause in boxes. Right, it only matters up here. Cool. What issue could there be with this? Oh, right. Missing a paren. Okay. Next pause. So the pause that's right ahead, and the pause that's ahead left. Let's just make these functions. So I want to check if a position is occupied. So def occupied, and this is only for part 2. So I'm just gonna write it 2 by that. Occupied 2. Given a set of boxes. Hmm. And maybe we say where it is exactly. Well, no, we don't need you need to do that. So occupied some position. So it's basically this or oh, occupied depends on direction. No, it doesn't depend on direction. We always just look to the left. West. Not that or that or yeesh. I'm gonna forget this somewhere. This is walls 2. I swear that's gonna be the bug that gets me. Also this should be pause. So that or boxes left or walls 2 left. And now tell me if a position is occupied. See films. Hello, hello. Okay, so if occupied, or if not occupied, hold on, it's occupied if any of those are true, right? Yeah, so you want to write that a little bit differently. All on one line. So if not occupied, I could just do an occupied 1. Honestly, I'd rather write less too specific. So given a set of boxes, oh, well, no, this is by nature going to be too specific. This is why you don't use global variables. Okay. I'm doing all right. I'm feeling pretty confident about this part 2 here. I just need to get through it. Okay, if not occupied, then we just keep everything as is. Great, that's easy. Otherwise, if walls next pause, or let's see, let's take head left, val, head. No, it depends on the direction you're moving. No, actually, it doesn't matter at all. So if walls next pause, or walls next pause dot move dot west. Okay, or the piece to its left is a wall. Then we just stay still. And then I guess we have to check all far side points now. And then we have to determine what gets moved. Well, okay, so as long as there's a single box, nothing gets moved. And otherwise, everything gets moved, right? Yeah. Otherwise, everything gets moved. Um, so we have to find all the boxes that stem from somewhere. So starting from a position and given a direction, we check all boxes. Then we can just check the north side of those boxes for any walls. So let's do that. Def connected boxes from a point and direction. And this is kind of, yeah, this is the analog of my far side method from part 1. Other side boxes, I'm going to rename that right now. Far side boxes. Hey, Blue 1986, welcome back. It's been a while. Oh, you have an illness after the company Christmas party? Lots to catch up on then, huh? I've been doing, well, maybe not so great. The last few days, I have not been getting sleep. Yesterday, I was supposed to catch up on sleep since it's the weekend, but didn't happen. So I've had a few long streams, but they've still been fun. Yesterday's problem is an AOC highlight for me. It's like the kind of problem that really sets apart, like this is what sets AOC apart from leak code. Um, so where are we here? Have you started on today's at all? No? Well, I'll be curious to know your progress and what you're working on. Um, where are we here? So connected boxes, we're gonna return a set of point for the boxes that are connected from one spot. And we can do this recursively. Our map's not that huge. Yeah. So we check a box. We check ahead. And if there's a box there, then we recursively check the spot in front of that and the spot in front and to the right. So if I guess we have to pass some boxes as well. We're just going to name this boxes 2 so that we don't forget to say walls 2. I hate that it's the same as a global name. Like I might forget the shadow. I'm gonna get namespace collisions. It's gonna get me. If I have a bug tonight, remind me to check for 2s. Okay, so if boxes 2 is pause.move dir has pause.move dir, then we add that to the set. Let's call that head val ahead equals pause.move dir. Then we return the head plus connected boxes recursively from ahead in the same direction. I guess with the same set of boxes. Yeah, totally. I guess the search can just be, there can be a recursive search function defined in here. Search. I'll just make the variable names shorter. Set of points. And yeah, ahead depends on where we're going. Let's just call this n. Okay. P.movedir That box is 2 for that next one. Then we do n plus search recursively from n. Right. Else, if box is 2, I wonder if we should do the walls here too. No. We'll just stick to boxes. So else if C Films is Scala a coding language, and what got me into Scala? Geez, I got into Scala like a decade ago, because I was getting into like functional programming languages. And at the time for me, it was like the best of all worlds of Python for the conciseness, Java for the objects and classes I was familiar with, and Scheme for like the functional programming aspects. And there's more to that story, but that's a longer story for another time. But basically, yeah, I was getting into functional programming languages. So let's say boxes 2 has not next, but ahead and left. So well, hold up. This depends. Does this depend on your direction? This depends on your direction. This is only if it's north or south. If it's east or west, it's the same old algorithm. Okay, let's make a note here. North or south only. Right? Hellhound, hey, hello. You kept pushing half boxes around. Well, if you represent them with only 1 point, you can't have them split. But I'm still doing my recursive search of connected boxes here. Arrow bounce, you lost 5 minutes in part 2 due to a single missing character. Oh no. So are all 3 of you finished? Zara, Arrow Bounce, and Hellhound? I'm so scared that I'm going to have a bug here. That's basically because of the namespace collisions. Because I like copy pasted code from my part 1 and I'm modifying it. And I just like slapped a 2 on the end of some things, but 1 is still valid. I'm gonna like shadow a variable or something like that. So if box is 2, let's look ahead and that move in direction out west. So we'll call that, yeah, like the ahead left bit. Then we search recursively from there and plus search. Yeah, no. We gotta give that a name. And that move toward out west. This comment, let's just make that an assert. I don't want to have an accidental bug. Assert dir equals, yeah, there we go. But rank 450 on part 2. You pointed on part 1. Congrats. The way you do DFS can accidentally become BFS. Great. All right. Just to let you know what I'm thinking here, I'm just planning on having like, 2 recursive searches down the left and right side of these boxes. And since they'll be sets, I don't think they'll be, well, I mean, I risk. I risk having a lot of duplicates. It's going to be only if it's like a big old pyramid. Then I get to the. It's gonna be like some n squared and a number of layers of the pyramid. I don't care. That's not gonna happen. I hope not. You'd have to like specifically um, specifically make your input likely to do that. So here we search ahead in the n space. Let's call things NL and NR. Val NL. So it's we move ahead, then we move left, and val NR. Why am I doing this? NW and NE. Okay. So if it's not really north, it means next. N means next. It could also be south. So we would recursively search if there's a box ahead or left edge of box. Now we'd also search northeast, right? Otherwise, if there's a box that's ahead in the northwest, then we're going to return northwest. And search recursively from both that northwest point and the north point, right? And of course, it doesn't realize we can add that, so we're going to put that at the end. Otherwise, we just give an empty set. Oh, no. We have to give a thing. The current position? Well, the first current position is they get added here. So this can be an empty set. Okay. And the search required, oh, we're gonna union those two. Just do that, right? Cool. Or isn't that union for a set? Ish. It doesn't like the order of operators there. Okay, union. Set that empty point. Fine, I'll give you a type. Okay, so now we search from pause. Great, so we can get all the boxes. So we have the case when this next point's not occupied. Great. Otherwise, if there are walls in the next point, in theory, I guess these two could be collapsed. So, but easy case, leave that there. Otherwise, there's a box in front of you. Instead of far side, we'll just say connected boxes. And for each of those, we check if there's a wall. So if connected dot for all, we check if ahead and ahead to the left is no wall, right? So we'll call this no walls. Okay, so for all B, for all of our boxes, let's see, let's take B dot move in our direction. Oh, and again, this depends on if it's north or south. Let's just, we'll see if we can collapse the cases later. But if dir equals north or direction equals south, what is this crazy autocomplete? Okay, so we're gonna move in our current direction. We'll call this n. And if n and the piece to the left, so val nw. So if not walls 2 n, oh, you know what? I'm glad like Copilot here is keeping track of what I should be doing here. I don't trust Copilot on this, to be honest. So in that case, what is our next state? We successfully move, so we do next pause, and then our boxes. Oh, wait. You don't need if else here. We're defining a Boolean. So if walls, I guess we're doing if no walls. So if no walls, then you basically copy paste this old code here. All the boxes will move. So we're gonna take boxes 2 minus connected plus connected.map move in that direction. Cool. Easy. Okay, part 2 isn't that bad. Am I there yet? Not quite. I'm almost. In Icy Black Deep, I would not have stored everything in strings if part 2 had been first. I felt kind of locked in having solved part 1 that way. Fair. Yeah, for stuff like this, I always do. I've gravitated towards doing sets and maps of points. So now we have an else. So otherwise there are walls on the far side, right? And it's just pods and boxes. Okay, and now we have another else branch, and we can copy our old code, sort of. No, we need to, we do need to write new code. So east and west isn't just like, we do have to check by jumping like 2 at a time. But it's very similar to our far side code. Far side boxes, we'll just copy this and call it far side boxes 2. So this means there is a box in the way, right? We've already checked, wait, walls? Oh boy, that's supposed to be walls too. Jeez, that's gonna get me. That is so gonna get me. I would probably have done some OOP stuff if I just went to part 2. Fair. Yeah, I get it. Being walled in by your first solution. Okay. So this does mean we have a box in our way and it's east or west. Let's have a far side boxes 2, and we're gonna make an assertion here. Assert. No, this is east or west. You know what? I have dir.horizontal, don't I? It's horizontal. Yeah. Okay. I think it's basically the same, except we just move twice in that direction. 2, right? Yeah, drop while dot next. Okay, so here we can copy our part 1 solution. Where is it? Yeah. Okay, far side boxes 2. Is it boxes or boxes 2? I'm just gonna rename this. Rename symbol to B's. Okay, if there are boxes anywhere in here, that's what's a mistake? B's minus next pause plus far side. Um, yes, that looks good. Okay, we just fixed the syntax. I think we have a syntax error. Outdent expected, but if found. So we indent, we outdent. That should be fine. That should be, oh wait, this is an if. Yeah, let's get rid of that if. Right. Gotta just put all those in parens. Okay, what else do we have? A missing parameter type somewhere. What happened here? Copy and then, okay. So we have a b, and we're gonna do b.x times 2. Was that Copilot generated code? This is kind of weird. Okay. All right. Not found occupied. Did I mean occupied 2? Jeez. If I hadn't occupied for part 1, that's a bug right there. Missing, what are my parameters for part 2? Pause 2 and the boxes. Right. It depends on the state of the boxes. I mean, let's just try this. So answer to, is 1. It's kind of the same thing, right? So ans 2 is just gonna be final boxes 2. To list map that some. No bugs works first time. 1507629. Okay, fine. There is a bug somewhere. There is a bug somewhere. We could print states step by step. If we turn this fold left into a scan left, then it should give us all of our states. That'd be the most straightforward way to find a bug, but let's just do a quick review over any places where you might be taking the wrong variable. So if occupied 2, right, so that position or the position to its left is a box or a wall, and it is walls 2. Okay, yeah, that looks good. Otherwise, if there's a wall, either in the next position or the position to the left, Okay. And does this matter east and west? This does matter east and west. So this only fits north or south. Um, well, hold on. No. This is the same east or west, right? If you're moving east, no. This is this is a case for north, south, or east. I mean, or west. It still works with it still works with west, or no, sorry, it still works with east because that box would be on top of you, and we should never hit that state. Yeah, I mean, we could do an assert. We could make sure that we never are in there. Um, oh wait, we'd have to put up here. Yeah, just put in a little assert just in case. Assert, uh, not these. Pause or walls to pause. Oh, we found a bug. Okay, we ended up walking into a box. How does that happen? So let's look in the east and west cases, or not east and west. Let's just look in these last two branches. So if no walls, then we can move ourselves to the next pause, right? The robot's in the next pause. And boxes to minus connected. Connected should include the next pause. Okay, we'll check on that and make sure it includes the next position. Now this far side 2, if there's a wall on the far side, then yeah, this is good. Oh, if there's walls on the far side, this is east and west though. So far side does take into account the plus minus 2. Oh, hold on. When going east, this is different. Okay. So if east or west matters here, so our start, let's still move in increments of 2, but we'll change our start. So val start equals if there equals west, then okay, we're going west, so we can go into the invisible boxes, then that's fine. Then it's pause. No, let's do it this way. We'll do an else pause. So if it's going east, then it's going to be right in front of you. So for this move twice bit to work, we're just going to step backwards a bit. So pause dot move direction dot opposite, or just west. Okay, great. Let's try this new answer. Oh, wait, we do get the same answer. Hmm. Even though we fixed a bug, we got the same answer. That's weird. At least 779 people. Only 779 people have done it. Can I still be in the top 1,000? No way. 15. Wait, how do I check that under stats? Yeah, okay. No, that's over 1,000 by now. How'd I do on part one, by the way? 1600? Oh, right, we never used a start. But how did that fix a bug? Whoops. If that indeed fixed a bug, then that should be... I don't know why that assertion ever failed. Oh wait, let's put that assertion back in. Ah, so it's not a problem with east and west. Let's check north and south then. So, the connected boxes, we remove all the connected boxes. And then we add in a copy of all those boxes moved, north or south. So that in theory is right, as long as that we choose the correct connected boxes, right? And the walls thing, I'm going to trust that for now. But our connected boxes method, I want to be careful about. So let's make this assert variable. There we go. Okay, so we search from a point that's getting pushed into, right? This could be the robot. This could be a box moving into this position. So this is ahead of where that would move, and to the left and to the right, just in case, right? So if there's a box directly ahead, then we add that box, plus a recursive search from that box's position pushing, and from the spot to the east pushing. Okay. Otherwise, is northwest right? Yeah, northwest, because that's the location of the box. And then recursively searching from northwest pushing up, and then north pushing up or down. This should be should work in either case. Okay, so that's fine. We should just be writing tests, or at least doing a spot check, printing these. We can print these pretty easily. But I just wanted to see if I could find a bug real quickly. And there's one last thing to check. It's just no walls. So we check all the connected boxes, and for all of them, we check if there are no walls in front of them. So we have a connected box. We move it directly north, and then there's north and west, right? And we check that neither of those two are walls 2. I think I might rename walls 2 as well, just so that walls, here it is, here it is. I found a bug. And didn't I say this is the bug that would get me? Right here. Some namespace collision. Okay. 1509774. 1509774 is wrong. What ranks did you guys get, by the way? I do want to print this, but I do feel like, oh, here, far side boxes 2. Here's another case. Wait, we pass in walls? We should be passing in boxes. We shouldn't be passing in anything, actually. No, these. Yeah, and then we're passing in boxes here. We don't need to pass in anything. right? Yeah. And drop while walls 2. Oh, no, that's not walls 2. This should be boxes. Um, wait, no? Wait, for part 1, I did this with walls. Um, but for part 1, I'm pretty sure I passed boxes in. Yeah, so that should be boxes that we're passing in. Types. I should have given these two things different types. Okay, so rename walls to boxes. And you're just passing B's. Okay, that should still be the same answer. But I'm semi-convinced that I might have fixed all the rename issues. Now let's just take a look. Blue, how's 13 and 14? Are they doable? 14 part 2, I'll say this much, it's vaguely specified, so there are many ways to solve it. It makes it fun. I really like it because there are many different ways to solve it. You have to figure out what you're looking for, and then you have to figure out how to find it. Right? And there are different ways to figure out what you're looking for, and there are different ways to figure out, there are different ways to find it too. So I think that makes it really interesting. I can't remember day 13 off the top of my head. What was it? Day 13? You could do it on pen and paper. Yeah, you have to guess what you're looking for. Mhm. Yeah, day stacking can end it. Okay, it's time to print stuff. It's about time we print something. So let's do some debugging. What do we do here? So we had a fold left here to calculate the final state. We're going to turn this into scan left. Scan left. There we go. And that'll give us all the intermediate states. I'll just name them states. Well, states. Okay. And just so we still have an answer here, this will be states.last. Okay, so no other code breaks, but now we can take each state and print. States dot for each. And I guess we can do an area.draw. Area.draw. We're on TV with the raid, 18 viewers. Welcome, welcome, welcome. We're having more fun. Here, I'll scroll on the right side what my part 1 solution was. It's the general idea. Where is it? Right here. Just iterating over states. We are adventing some codes, yes. Yeah, I'm enjoying this one. It was like a week ago. And you know what? I was reflecting on that. It seems like every year, day 7, I have a silly thing that costs me a lot of time. And every day 7, I think Part I'm drinking. I'm drinking going into day 7. So here we are just doing some printing for part 2 right now because I do have a slight bug. I I feel confident about my approach, and we're not gonna have performance issues. But I have a bug, so we're gonna print. Um, so we have all of our states. What is our state? We have a position. I know pause, and then we have boxes. It's day 15. Oh yeah, that was a week ago. That was a week ago. Today I'm just slow because I'm slow. No, I'm not stuck or anything. But I would like to get a good night's sleep one night. I thought it'd be last night, and that wasn't it. Oh yes. In case any of you don't know, Eric Wassel here is the creator of AOC. He won't drop any spoilers unless you trick him into doing it. What am I doing here? So we're drawing some P. If okay, so if box is P, or box is 2P rather, or no, yeah, or box is P and we check to its left. No, those can be different. So if box is P, then the character is that, just the left bracket, and these are cases. Great. Yes, Eric Wassel is absolutely a VIP around here. Area. Wait, we defined area earlier. That should be fine. So if the spot to the left is boxes, then we draw this right bracket, right? And if it's walls 2, and if it's walls to the spot to the left, P dot move dot west. Let me also draw that. Otherwise, we draw that. Well, we need to check for the actual position. So case P if P equals pause. Or, we could do this. Pause. Oops. Otherwise, we draw a dot. Okay. Is there a problem here? Oh, this is gonna be like P if boxes. This should be an if then else branch. So if box P, then we do that. Else if, oh, can it autocomplete to refactor? There we go. There we go. Reddit is positive about a bunch of things. CRT on people? What do you mean? Oh, Chinese remainder theorem. Yeah. Also negative. Reddit's very positive and negative. Cathode ray tube. Yeah, let's do another cathode ray tube. Don't you people have maxima for this? Oh, I see Black Deep last year, day 24, helped me implement Gaussian elimination to solve that. We were up late doing that. let's take a look at this. So this is printing already. Um, I know we are making a Scratch 4 because Scratch 1 through 3 I'm currently using. This worksheet app actually copy. Give me a second. Oh my god, this is like bugging out. What does the colon then indented lines mean in Scala? Um, it depends. Oh no. I'm just gonna close this. I'm gonna restart. Um, basically, the colon then indented lines could be a replacement for a function call, right? So normally, like you might add parens and then some parameter and the arrow, and then moving on. So colons just allow you to do that without the braces. And that is unique to Scala 3. So Scala 3 has like the Python looking syntax. I don't know why it thinks that's R. Okay, we're just gonna let this run again. But see, this states that for each could also be written as you know, that basically, and then you do something with pause and boxes. Printline in this case, this is a function that just takes a single argument, and that whole argument is here. Yeah. So printline, it's also the body, right? Printline just takes a thing. For each takes a function. So it's nice. It kind of unifies that. Okay. Now we've been stalling on printing this for a hot minute. And we're going to change this to Scala here. What am I not copy pasting? Oh no, it's happening again. Okay, I do have to pull up HTOP. I don't know if my stream health is still okay, right? Something is running. Let's take a look at that off screen. Huh. I just seem to be unable to paste. And it's evaluating. It seems to be continuing to evaluate day 15. Oh, okay. Here we go. Here we go. Maybe I just tried to push paste too many times. Okay, now we can see what's happening. That's a lot of lines. Wait, how many states are there? Maybe I'm just. Maybe VS Code can't handle this much text. Look at that. That's like a million lines. That's what's happening. Or start with the example. That too. Mm. This is not the kind of thing we want to be spending time on. Oh, but look at that. We are having a bunch of boxes being pushed into each other. We can already see a kind of bug happening here. Do you see that? It's only happening on that one side and not in the other side. Okay. So we found I know what it is. Okay, when we're pushing east and west, we are pushing by 2. We should be pushing by 1. Wait. Yeah, we're pushing by 2. Um, it's very possible. Well, yeah, the boxes are pushing into each other. I think I know. I know exactly what this code is. I'm just gonna close VS Code real quick. It can't handle that much output. uh, yeesh. That isn't something I've done to VS Code before. It's no, don't open that file. Don't open. Okay. um, states. Let's take 100 of them. Actually, you know what? We don't really need to debug that anymore, but we can print that just in case for fun. I don't know. Um, but far side box is 2. So I just copy pasted my far side box as 1. And what it does is it removes the next position, right? And then it adds the far side position. But that would only work if you push them 2 at a time. So we have to get all those boxes and increment them. Um, I'm going to do this. I'm going to return a set of boxes. I'm optionally going to return a set of boxes if there's no wall. So this next bit is the potential wall, right? Is the far side. Well, I mean, we can keep that just to make things faster because I think this might be the last bug. I'm going to change this code here. And let's basically do, yeesh. We're going to copy paste this. Horizontal boxes, set a point, or I don't know. Yeah, a set a point should work. And instead of next.next, we're going to do a take while. So we're going to take while it's a box. So that gives all those boxes. Val boxes to move equals horizontal boxes. And let's see, we take B's minus boxes to move. Oh. And then their new positions. So boxes.map and I don't know, move in the direction we're moving just by 1. So val new box position. I'm just gonna inline that. Okay, easy. Let's try that. I do want to hit the 500. I wish I was going to be finishing the 500 Star Club this year, especially since the theme this year is historians and that's going back through all the references. Missed opportunity. Oh well. Take while is not a member of iterator. Oh, no, you just need to capitalize. And then 2 set. Okay. So that should work. Let's not even bother taking these. Let's just look at our new ANS 2. 1507629. That's that's an answer I got earlier. Weird. We fixed a bug and we got an earlier wrong answer. How many stars do I miss? I don't know. Let's look at the events page. So I started doing admin of code in 2021. So I've hit everyone every year since then. And the rest of these are just me going back through the past years for practice. And these I've done. I've done all of these on stream. So like this year, I was practicing 2018. A couple years, mm, I think a couple years ago, I was doing 2019 problems, and I was skipping through only the what was it? The computer in there. The int code machine. The int code machine is super cool concept. 2019 is a fun one if you're looking at past years. Okay, so let's go back to printing. And this time we're going to print a same number, just 100. Yeah. Okay. Now we can copy this worksheet output without killing the computer. Interesting. I don't know. My copy paste is only getting spaces. Is it not able to like how much is this output? Like what's area dot size? Um, it's not that big. Like we've seen it. Yeah, it's not that big. I just want to see this. Hmm. It took you twice as long to build this normal years. I believe it. Yeah, that seems like it was a lot of effort, but so fun. Wait, why are we here? Okay, I'm just gonna take 10. Surely we'll see a bug by then, right? Unable to export, fixing diagnostics, save, try again. Nope. Any message here? Ignoring decorations. Non-active document. What does that mean? No problems have been detected in the workspace, so I don't have any errors or even warnings here. Fine. Okay. This is going into the REPL. We're gonna turn this into a not worksheet. We're just gonna turn it into like a normal file and compile it. Um, hmm. So let's save this as day15.scala. Um, at main def 2024 day 15. And that just returns unit. And we can do all of this. Oh, we can't name it that way. It has to start with a letter. We do this package 2024. Okay. So we run that in SBT. And oh, but now there are forward reference over definition of states. Yeesh. Okay, let's look at that. We have a forward reference. How's that not caught in the yes, right. Not valid outside of worksheet to do that. Okay. Let's print this. Print line ends 2. And we still have an issue here, unused local definition. Well, that's not an actual issue. Horizontal boxes is a for reference, right? Let's move that too. Neither of these should cause bugs in the worksheet. Okay, we're running 7. And these are the first 10 states. Okay. So where do we start? Here on the right side. And we're just going to walk around in empty space for a while, aren't we? And then we touch a wall. Oh, interestingly, we're not printing the whole thing anymore. The area for part 2 is larger. I don't think I actually use area in part 2. Let's check area. Yeah, so let's define an area 2. Area 2 equals, what do we do here? We'll just copy them all. Width times 2. No, right. So if left is just 0, that should be area.right times 2, right? And bot. It's not wider any there. Oh, we can just do like area.copy. And the only thing that changes, nope, that doesn't work that way. Okay. So we're drawing from area 2. And let's drop 10 and look at the next 10 states. This is just bot. Okay, let's rerun that. So much snappier when you compile things. Like the worksheet is a little bit of a trade-off. Oh. Where's the first state though? We should be indexing these, naming these. Okay. Right, now we're in the center. This isn't a very good way to view this. Okay, here's a better way to view this. Let's move to the example problem. So day 15, 2024 dash example. Yeah, this is a scaled up version of part 1 of which one? The larger example from above looks kind of like this. Where is it? This one? That's the end state of it. For example, here. Right. Okay. Um, 2024 dot day 15. Okay. Here we go. Let's take a look at these. Oh, and actually, I think we want to print other thing. Let's just print all of them for that. Or how many states? How many states do they have in the example? Not too many, I'm sure. So just do states for each print line. All right. Um, I'll open a new REPL so that we don't have any history to look at. Okay. Oh, wait to the start. There are still quite a few states, but there's enough that we'll be able to find something here to dig into. Is this really the starting state? Example 2024. That is not the starting state. Is my starting state incorrect? No, those are all used the end state. Yeah, they're all printing the same image. Okay, let's fix that real quick. Wait, each state should have a different set of boxes, right? Yeah, it comes to its boxes. I'm drawing based on those boxes. Let's just rename this real quick. Oh, fine. So these should all be, nope, I'm not doing that. Hmm. Am I muting boxes? No, I don't mutate the boxes. So each state is just calculated from the previous one, right? So here we have start to, oh, here we're using boxes too inside of here. Didn't I say at the beginning, I've called this many times that this becoming my downfall is namespace collisions and like failure, like, yes, using the wrong variables. Okay, let's try that again. Okay, well, now we can, we're still printing the end state. Okay, so I think we're passing along the end state somewhere around here. Boxes.map. No, this is supposed to be boxes to move. Boxes to move.map. Okay, let's try again. And actually, let's just change this so it prints the answer at the bottom. And we can verify that. 9701. So the answer here, 9021. So not correct, but now the boxes are still the same. Maybe you're reusing the grid between part one and part two. Yeah, it's possible I'm referencing the part one grid in part two. Very possible. Um, yeah, I'm getting halved boxes, but also I'm getting the same set of boxes in each state. A solution here might just be to get rid of all the part one code. Actually, that'd be a very handy solution. Let's just do that real quick. Get rid of all of that. We are gonna So we are using part one definitions to define the part two. So we'll just put them like in line. Yeah. And I guess we could just take that set and then dot map. Same kind of thing. Whoops. Wait, final box dot map. What was that? Oh no. I found a bug. We were defining boxes too in terms of the final boxes from part one. There's the bug. Um, okay, let's undo this for a sec. I just want to run. Yeah, here it is. Here it is. Jeez. And that's also that's also like a forward reference. Okay, let's try that. 8997 still not the answer we're looking for. But I still want to delete the part one code. I really don't want to be having these bugs. So this dot copy, we multiply start x by 2, right? Cool. And then we take this and we map walls 2, same thing. And oh wait. This didn't change because this wasn't compiling correctly because I deleted part one code already. So I'm just gonna rename that to start. I'll rename this to boxes. Okay, very dangerous thing. Moral of the story here. Don't just start adding twos on everything. Far side boxes we don't need. Area, that doesn't matter too much. Movements don't change. Occupied to whatever. This, you still have like a shadowing issue potentially, but this should at least fix that. Okay, pause. What's the issue here? It doesn't have a definition for start in boxes apparently. Yeah. Okay. Val s. We'll just take s dot x times 2. Okay. And then we just return s dot copy. Okay. I think that's compiling again. So now we can run this, and that should give us the right answer, 9902. 9021. Okay, I tried to act confident. It seems like we pushed boxes into walls, but we're not having the split box problem anymore. We are still printing the wrong thing somehow. So let's take a quick look at that. What's boxes a reference to? Whoops. It's just this, right? In our final states. It should be distinct for all of those. Final boxes 2 is a set of points. Oh, hold up. This is what's going on here. Well, actually, no. We have our list of states. Movements is a list of directions, and yeah, this results in a list of Ron T sucks me back in. Or no, you sucked Ron T back in. I said I was gonna wait for tomorrow, but I want to at least try to figure out the expansion of the grid for part two. My starting position keeps getting overwritten. Oh, Ron TV, you didn't. You're staying up. So you ended your stream. You're like, I'm gonna go to bed and be a sane person, and then you're still up. Hmm. Yeah, I think we all hate Eric almost as much as we love him sometimes. uh, so, Ron, are you making progress? Is it Ron T or is it Ront? Um, yeah, this is weirding me out. Every state should be different. Let's just make that assertion. Actually, what are we? Okay, there's a boxes and there's a bees going on here. Here's another case, right? We're referencing the outer boxes. This should be bees. Yeah. Every time there's walls, it's restarting to the original position. That's why. There we go. Um, mm, okay. I think that might be happening somewhere else. Here, I have a strategy. I'm going to rename this symbol to something really long and see if it shows up anywhere else. Nope. We shouldn't be using that anywhere. Same with this start. Uh, it might be happening in one of the helper functions. So horizontal boxes, this only references boxes. I'm going to make this variable here longer because we don't want to be using it anywhere. Rename symbol, uh, boxes. Let's say start boxes. We can rename the start to start pause. And walls. I mean, walls is just walls. Okay. Are we using start boxes anywhere we shouldn't be using it? No. Cool. Better naming. Start pause. Great. Real name is Tony. That came from someone failing to type your name. All right. How do you do that? How do you do that? Yeah, one of my boxes is stuck in a wall. Does Scala have an escape analyzer? Like, what's an escape analyzer? Oh, hold up. I gotta turn this music down. I don't even know what it is. Okay, let's turn it back to lo-fi. R is next to it. Oh yeah, I see. R is next to T. See, I type in Vorax, so this stuff doesn't occur to me. Left hand shifted one key. I'm gonna keep this on loop, so every time we change the code, it will update there on the right side of my screen. Now, what else is there? It's literally, I've just been fixing variable naming bugs, so this is kind of ridiculous. So, learn from my mistake. I called it out that was going to happen, and I didn't do anything to mitigate it. Connected boxes is probably fine. I think, yeah, there's no outer boxes to reference now. And could it be? We're going to do an assertion on my states. So, what do we do? Let's do an unzip of states. States dot unzip. So these are going to be the positions and box states, I guess. And we're going to do an assert that box states that for all. I mean, sure, that's a good assertion, but what we actually want to do, not distinct, should be greater than 1. No, not greater than or equal to, just greater than 1. Okay, greater than 10. There should be at least 10 states. So that assertion fails. Greater than 2. Greater than 2 fails. So we're only having 2 different states. This, oh. We are starting to see things change. Our robot phases in and out of view. Okay, we move south. Our robot doesn't appear to be... Okay, it seems like... let's do this. Let's make the first if print the current position of the robot. Now, the robot should never overlap with any of those. And then we print the boxes, and then we print the walls. Right? Okay, let's see what that new bit looks like. Okay, so our bot is clipping through... Well, I mean, it looks like it's clipping through boxes, but I think we're just printing the wrong boxes somehow. Oops. I'm just going to rename these B's, just so we're not referencing the outer box. Okay, it's still the same thing. Our robot is moving around, but we're not even seeing how the boxes are moving. Bot states that distinct that size is greater than 2. So there are at least 2 states. Right? I think that errored at 10. Okay, yeah. So it is not a printing problem. It is a problem in here somewhere. So if it's not occupied, we have the same boxes, right? If there's a wall in the way, we have the same boxes. Cool. If there's a wall in the way here, we have the same boxes. A wall in the way of a connected set of boxes, right? Or if there's a wall on the far side of horizontal boxes. Cool. let's make assertions here that these are actually different from BS. So Val, next boxes or next B's, let's say, next B's equals this. So assert next B's is not equal to B's, right? And same kind of thing here. Minus the connected bits plus the connected moved in the same direction that we're moving. Okay. And assert. And let's remove this assert here so that we can see that new assertion fail. Functional programming in Dvorak, that follows. I guess so. Identifying the risk is the first step to mitigating the risk. Okay, good night. Good night. Thanks for stopping by. Always fun to see Eric in chat. So what is an escape analyzer? Oh, looking for escapes. If a variable escapes the function it's defined in. Escapes the function it's defined in. How would it do that? I don't think that even happens in Scala TPH. I guess you'd have to use some sort of mutation to do that. Okay, let's run this. We are getting an assertion error. At which line? Line 95. So this one is failing. Okay. So these are the boxes we're moving, the horizontal boxes. Okay, so at some point, moving that set of boxes, let's make another assertion here. But that's not empty. Horizontal boxes, not empty. Okay, let's try that. Okay, we're having an empty set of boxes. So we shouldn't even be getting here if we don't have any box that's in the way. Okay, so we check the far side of the boxes. Let's look at our horizontal boxes method. Right, this is where we just sort of copy paste this and made that work. Take while boxes. How do we get there? Because this whole thing happens if there's a box in the way, right? Let's make that assertion real quick. Yeah, so it's B's. Next or B's next move west. Why west? This should be east. This should be east. Yeah, that's a bug everywhere in my code. Okay. So let's start here. If the next position is a wall, or no, the next position and we move left. Okay, west. West is correct. So the next position, but we move left, is a wall. Because walls are now too thick, right? Geez, I should just make walls individual. Walls don't need to be too thick. We can just have two walls. but are not occupied check. So occupied also checks the left bit, right? Checks west. Okay. So this is if it's not occupied. So it must be occupied. If it's not walls, then it is boxes, right? So at this point, this should be true. That assertion shouldn't fail. Let's see. No box in way. Right. And I guess it's not pause dot next, it's just next pause. Okay, yeah, that doesn't fail. We're failing to find the boxes that are in the way. And I want to know what direction we're facing when that happens. So let's print that in here too. Yeah, let's print the direction. Oh, that's so much easier to read. So horizontal box is not empty. Oh, wait. We didn't want to put that there. We wanted to put that here, the direction. I have a suspicion that only happens in the east or west case. Okay. In the west case. So start, if direction is east, so here in the west case, we just start at the position. We are moving west. So if we move to the left twice, right? If we move to west twice, in fact, we could say, what is this? This is we could say dot west dot west. That should be the next box, right? We drop one because that's a start. That's not one of the boxes. This is the robot's location. Oh, no. Yes, that's the robot's location. So west twice to get the point where the box's top left corner is. And then we take, we take while those are boxes. I think we got to explore here a little bit. Let's go back to the worksheet. I want to make sure that algorithm works properly. So horizontal boxes. Right. I don't know. Let's do. So let's define a new set of boxes. Let's just do 1 point. So point, let's say 0, 0. Well, hold on. Hold on, I'm just failing to see. I'm not actually sure what I want to test there. Move twice. Take as long as the box. Why would that be? So there is a box in the way, right? There's a box in the next position, or there's a... Okay, I want to know when I get my assertion error here. Not just the direction we're moving, but what is ahead. So let's do next pos. Or let's see, I want to know if next pos is a box. So B next pos. And then I want to know if B's next pos dot west. Okay. And I want to know our current position. Okay, we're at 0.84 facing west. And the next position is not a box, but the position after that is a box. Okay, so nothing funky happening here. I'm just going to rewrite this boxes to move. And let's make it very explicit. Let's make it very explicit. So if direction is east, else if direction is west, or we just match in the direction. So dir match. So if it's east and if it's west, and otherwise we don't know what we're doing. So we're gonna do like an iter. Oh, hold on. No. It's gonna be two sets. So we're gonna iterate iterator dot iterate from. Well, if we're going east, then the next position is what we're looking for. So we start from next pos, and at each step we move east twice. East. Yeah. And then take while boxes and two set. That makes sense, right? And now here we will move west and west, sure. But we don't, the first box to the west is going to be 2 to the left. So it's going to start at next pos dot west, right? And again, we take while B's and then two set. Otherwise, we throw some error there. And great, let's see if our assertion. Okay, unused definition, cool. Now we have a different assertion error failing. Great. So we fixed that bug. Now where is this assertion error? It's at line 79. No, hold up. It's day 15, line 68. No, it's actually later, 84. Okay, so we have a similar thing happening here, I suppose. Next BS is not equal to BS. So it should be moving once we move everything in the direction. How's the grind? All right. Tonight I had a bunch of bugs coming from namespace collision. I dumped all my part 1 code. Well, the part 2 codes are like in the same file, right? And I was like, oh, I'll just slap a 2 on it. I'm gonna regret this later, and I'm regretting it. But I think we're past all of that now, all the naming issues, and we're just doing real debugging. So we have a case here where, let's just call this vertical. Okay, when we're vertical, and if there are no walls in the way, we are somehow not modifying these. And I suspect it's a similar thing. It's that these connected boxes are empty. So let's make that assertion. Assert connected that no empty. And try that out. Let me put this in the top right. Okay, so what are we seeing? No connected boxes. Great. So we're at 10, 7. We're facing south. And the next position is a box. The next position is indeed a box. Okay, let's look at our connected boxes method. The goal here is to get the set of boxes that would be recursively pushed by this box, right? So given a point, I suspect this might happen in, well, we'll see. So given a point that we're searching from, and we are searching, we're searching from next pause. We should be searching from the current position. Yeah, that's a problem. Yep, that's it. And we're probably doing a similar thing. We probably were doing a similar thing down here. Searching from the next position instead of the current position. Okay. Let's see if we get... we still have some... 9822. We don't get the right answer yet. And we still have some weirdness going on. So in my printing code, we're not seeing things move around. What kind of assertion can we get to? So I have checked the number of states. I want to check the number of distinct states and make sure this isn't actually a printing issue. There should be at least 4 different states of positions, right? Oh, interesting. So the box states are in fact distinct. Yeah, that's running no problem. Okay. And we might as well let that assertion run too. So this is just an issue with how I'm printing things. And again, I might be printing stuff from, well, no, we don't have part 1 anymore. Okay, so we just did an assertion that all of these sets of boxes, box positions are distinct, right? That's what this does right here. So every time this runs in this for each, we get something different. Right, and we can move that assertion closer to it, just to be really sure. I'll just copy the assertion actually. Oh, states is different from box states. Let's write this differently. So let's do states.map _2. So states is just the positions zipped with the boxes. Let's check that assertion. Okay, because that's essentially what we're doing here. Um, I mean, this looks like the kind of bug you get when you have mutation. You're close. I am too. I've been close for about 2 hours. Uh, this looks like the kind of bug you get when you have mutation, but there's no mutation here. If connected finds a wall, you should not do anything, but you push into the wall. I wait, hold on. No, I don't think that's true. Let me check that. So, connected. And if there are no walls, I push into the wall. Otherwise, walls, then I just keep the same set of boxes, and I keep the same position as well. And I'm not sure if this is actually a bug here, that a box is in the wall. Actually, yeah, let's make that an assertion. I was wondering if that's like a printing error, because I don't think I'm printing correctly, because it seems like my states are all distinct, right? Um, yeah, let's do an assertion. So, oh, let's reintroduce this assertion that we never end up. Okay, so our bot ends up walking into a wall at some point. Oh wait, no, that's just compilation error. Walls two. This is walls. Yeah, we don't have walls two anymore. Okay, so our bot never overlaps with any of those. Let's make sure that boxes and walls never overlap. So assert um, boxes dot no bees. You know what? I'm gonna rename this. I'm gonna intentionally shadow. Oh, it's just called start boxes now. Yeah, we can rename bees to boxes. Um, okay, assert that boxes intersect walls is empty. Ooh. Okay, and I want to know kind of when that fails. I want to know what happened before that failed. So maybe we add that assertion. Oops. So let's just make a note that this assertion happens at the start, but I want to put this before a recursive call. Um, let's just in this connected case. Right? So this means it happens in connected. And let's also do it down here. East-west push. But it's not boxes, it's gonna be next bees. Okay, assert next bees. There we go. I'm writing asserts instead of just testing in worksheets. Um, I think I need to change this too. So next bees intersect walls is empty. Okay. Assertion failed here at connected. Okay, yeah. You are in fact right. So we end up pushing into walls. So our no walls function isn't quite correct. So connected um, for all of these connected boxes, we check the box moving in that direction and make sure that's not a wall, right? So okay, we're missing a knot here. Do you see that? Okay. So Now we're having the same thing happening in the east-west push. But hey, we fixed another bug. Um, east-west push. So next beads is in fact intersecting with walls. How are we deciding to be in here? There's a wall, and oh, right. When we rewrote this, we didn't check that the other side is not a wall. Well, actually, no. If walls, far side. Okay, so I suspect my far side 2 code is wrong. I'm just gonna inline that. And I was happy with this. So I'm gonna do something kind of like this. Um, okay, so the far side, this is gonna be a drop while boxes, right? And yeah, far side is a set of point. No, this shouldn't be a set of points. This should be a single point. So we're just gonna do the next. Chi Impact with the raid. I haven't seen you doing admin code yet. I mean, I guess you're done early. Hello, hello. Welcome, all of you. So, as you might have guessed, this is part 2, day 14 of the code. And great. I think you just saw me fix my last bug. So I'm gonna run this on the on the real input. Let's turn off my printing code. And then, oh, okay. Now we get assertions failing on the real input. And then I could do a walkthrough of what my approach is. Yeah, Eric was here for a while. Blessings by the way of Ron T. Ron T rated earlier, and I think Eric was part of the audience. Okay. We have an assertion failed, east-west push. So there's still something weird about my printing code. I don't know why. It's just showing the final state on every print. That seems like straightforward to debug, you would think. But no. Right, like this is clearly saying that all of my box states are distinct, or there are at least 10 distinct configurations. But when I actually use them here, they're apparently all the same. I'm not gonna worry about that for now because we're not trying to print. We have an assertion failed east-west push. Okay, somewhere around here. Yeesh, so many assertions in here. So that this means that we had a box intersect with a wall when we were pushing east and west. And I think earlier we were getting an issue because sometimes we'd have the boxes to move be non-empty. That's since been fixed. This would happen. This would intersect if the far side was a wall. Oh, hold on. Yeah. Nope. This project will rank help me jobs. I don't know. I don't know. It's not really the kind of stuff you do in a job, but it could impress someone. How's your project Ola rank? Okay, so this here iterates to search for a far side of a series of boxes, right? We drop while they are boxes, and then we take the next bit. And if it's a wall, then we do this. Otherwise, we are in this code, and apparently we do end up intersecting with the walls. So we take boxes, we subtract boxes to move, and we add boxes to move, but pushed in the direction that we are going. Um, okay, we can do some other checks here. Let's say whatever the far side is. So walls is in far side. Let's make an assert. Assert that boxes to move doesn't contain far side. I want to know what wall it's intersecting with. In fact, we can modify this assert error message to show that intersection. I'll just copy paste that. Okay, and here, what did we want to do? We want to check that the far side isn't in the boxes in the new positions. So next bees contains, so not next b does contains the far side of the boxes. Okay. What is this? East-west push, and we have a false. Wait. Intersect. We don't want the is empty. Okay, so it intersects with the wall, but it doesn't intersect with the wall that's on the far side. So let's see what points those are. And while we're at it, maybe let's start with that. You don't want this is empty bit. You just want to know what that intersection is. How many walls are... Okay, and we can't really do anything with that if we don't know our position and the walls are pushing. So let's add that to our error message. And then let's do our current position, the direction we're trying to move in, and I guess the next boxes. Yeah, that should be something. Oh, that's a lot of boxes. Oh, that's a lot of boxes. Yeesh. That is so many boxes. And do those all share the same? They don't even all share the same y height. Okay, so the boxes to move. Let's make an assertion on that. Assert boxes to move. That map. Y locations of all of those. That size is equal to 1. Right? Boxes not horizontal. Okay. Oh, okay, they are horizontal. What are we printing then? Next bees must be doing something kind of crazy. Let's do this assertion. Oh, hold on. Yeah, next bees is the position of all the boxes afterwards. We don't want that. I think we want the moved location of the boxes. Let's just start with boxes to move. Let's see what we were moving. All right. So this is the intersection. We have 62, 20. Our current position is 62, 20. Oh, the position we're currently at. That's not good. And we're moving a single box at 61, 20. Right, so this is to our left. We are overlapping with a box. So at some point, our character walks into the right half of a box. Hmm. So pause that. We want to take the west side of the position. Let's try this assertion. I expect this one to fail. No, that doesn't fail. Right, the position to the left of the player shouldn't be a box, of the bot shouldn't be a box. That's what that says. Yeah, the intersection contains that. This is our current position. I should have given these names. So let's just make our error message a little bit easier to work with here. So pause, ter, wait, what even is this? No, this is the wrong place. East-west push here. So this is the intersect. And position, direction is self-explanatory. To move. Okay, yeah, to move is one that's directly to the left. So, if the player ends up flipping into a box, then this assertion should fail, right? Right here at the start. Position.west. I should go through and clean up the code a bit. I think it'd be easier to debug if I did that. But I feel close. So let's give this a minute. Okay, it could be that I'm calculating the boxes to move incorrectly, and actually, that's probably the case here. So the very first box to move when we are facing east is the box at that next position, right? It's going to be our pause at east. Yeah. Oh, hold on. We're looking east. We are looking east. And the box we're trying to move is to our east. Oh, no, this is fine. This is fine. We're not clipping into a box. Okay, cool. So we're just moving a box that's directly to our right. Great, single box. So I want to see this map move direction. Let's just print that as part of our error message right on the end. Okay, so it was successfully moved to 6220. Right. Which is a wall. So we're failing to find a wall on the other side of that. We're failing to find a wall at 6220 where that box would be moving. Okay, so the far side wall, when we're moving east. Ah, yes, yes, yes. We have to check. We have to check the double width walls. I actually want to change this. Um, I should have done walls as individual points and kept boxes as two things wide. But I think we found it. Is there a command that answers your top frequently answered questions? No, there isn't. But you can ask a question. And if it gets asked frequently enough, maybe I'll just add it to a FAQ. Okay, we're going east. And we iterate twice at a time, and we drop all boxes. And then the next bit is a bit that could be a wall. But the bit right before that should be checked if it might be a wall as well. So at this point, the box is already clipping into the wall, right? So to move is 6120. But the wall point is at 6220. So the box is already clipping into the wall at that point. So the mistake happened even earlier. So I think I want to do another assertion to catch that earlier. Is my name really Stuart Stewart? Yes, that's my mother's sense of humor. Why Scala? Well, it's mostly what I use for work for the last decade. And I got into it because it was a nice combination of Java, Python, and Scheme. You know, functional, concise, object-oriented. Also, Scala pays well. But that's why I got into Scala. Why I'm still in Scala. It's a great community, great ecosystem, a lot of really cool tooling. Um, a lot of good type safety to work with. Often fintech, yeah. Often fintech and banking and commerce. Streaming. A lot of the streaming services use Scala. Okay, so why would we end up clipping into the wall in the first place? Again, I guess that's a failure to find a wall on the far side when we're pushing east. So the far side should be here. Next pause. This would be pause east, right? No, 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 no. We are looking for boxes. Yeah, and the boxes start at pause.east. When you're facing east, right? The top left corner of the boxes start there, one to the right, and we iterate twice at a time. And then after all the boxes, the next bit should be the left corner of a wall, right? So that's good. This one, on the other hand, let's say pause.west.west. Yeah, this would be the first. This would be the first wall or the first box that's to our left. We have to do it twice. We were only doing it once. I don't know how that causes my particular bug, but that's a bug. So let's try that. Okay, we're still getting the same thing show up, but that is definitely an improvement. I want to know how many steps we're in at this point. Maybe we do that. movements dot zip with index. Okay, we have an I now. Let's put that in the thing we're testing. We'll just drop an I at the end. This is not my usual debug cycle. It's weird for me to be doing like a real file instead of a worksheet. So this is after 9,403 iterations. Interesting. Holla holla one we them boys. Ola ola we them boys. Thank you for the follow. I don't know where this follower goal is coming from. But I guess I hit it. Okay. 9. Okay, so we know this is happening right at the start. Let's go back. I would go back to printing these. Let's see if another assertion fails if we take out this one. Because maybe another assertion is more helpful, right? Assertion failed at the start. Yeah, boxes intersecting walls. And then, of course, the same kind of boxes intersecting walls, just at a different place. Whoops. Right here. Oh, and this is with the real. Let's do a print. Maybe by now we fixed our drawings. Oh boy. Hey, you know what? We even kind of see animation. This is cool. Um, hey, we have an animation. It looks fine. I haven't seen any clipping yet, but there should be clipping at 9,000, right? Okay, I had to watch. Uh, that looks so good. I'm not actually seeing any clipping there. I'm just gonna paste that in. Okay. What if that's it? Answer's too high. Okay. Answer's too high. But hey, you know, that looked like something. Um, let's just retest again on the example. Which we were getting the correct answer in the example some time ago. 9021. 9021. Okay, this works in the example. The example's not going to help us find a bug right now. I wish it would help us find a bug, though, because this is so much easier to look at. Um, okay. Let's print just those states leading up to our bug, right? So what was the index? It was like at 9,000 something. Let's go back to today's actual code. Let's look at the index. I'm going to stop the printing. Turn on that assertion for the east-west push. Okay. Oh, we were missing the other side of the assertion. Okay, here we go. Okay, the assertion fails at index 9403. Let's just print those states. So go back to commenting that out. 9403. Let's take the 10 before that. So states that drop 9. Well, let's do 9400. And then take 10, and we'll print the ones after as well. All right, and maybe we should also print the index. So print the index before printing the next one. Need the case structure. There we go. No? I think we need an indent. There we go. Okay, so we got the bug at 9403, right? Where is our little robot friend? Right here. Ah, and it's clipped into there. Ooh, that's so weird. What happened right before that? So we were here, we walked down, and it was already clipped. It was already clipped at that point. Hmm. I'm surprised that our assertion didn't fail sooner, like closer to that. While we're at it, let's print the direction it's planning to go. So we have the I, and we have movements at I. And I think we want to find an earlier fail state. Let's just do this here. Box intersects walls. Oh, right. Because we're not, our assertion checks once it finally intersects, but we should actually check even sooner. Let's say box intersects walls. Clips. You need to search for clipping. So this is overlaps a wall, and we need box intersects wall. Let's just move all of the walls left or right. Let's move all the boxes right. So we want the right side of the box. So boxes.move, that map. Each position goes east. At that index. Okay. So let's try that. We get the index of the failure. 4464. Okay. So let's print that. 4464. I don't know, let's drop the 5 before the 10 before that. So 4454, and then take 10. Oh, and let's comment out that assertion. Okay, this is where it happens. We're pushing from north to south. Um, right? 4463. And we're facing south. We're about to push into it. Let's take one more. Let's take 11 so we can see it actually happen. Okay. So here we see we pushed a box south into it. Okay. Well, here I've been debugging east and west because I noticed it when we were going east and west, but it turns out the bug happened when we clipped. Um, so here we were facing south. Here we pushed both those boxes. All right. So we're failing to find walls on the other side of the boxes. So that we can debug. Um, so this is a vertical case, right? If no walls, yada yada, that's probably, I mean, no walls itself is probably wrong. So connected for all, we take the next position. So the next position it's going to move is in that direction. Okay. And then we also look to the west of that direction it's going to move. Yeah. Well, that's a problem right here. So this is actually E. We need to look to the east of the direction the box is going to move. Okay. That is our last bug. Let's take a look at our answer. Oh, hold on. Let's stop this printing. We can do a victory lap and print all of these later. All right. 150. Let's just copy paste. I had that show up last night. Okay, there's still a bug. There's still a bug. I try to act confident. Let's turn our assertions back on. So let's see if these two happen anymore. I don't think. So we do end up with a box overlapping walls. We don't get a box clipping walls anymore. Okay, well, let's find the index of that. And let's do some printing after we do that. So this is at 2299. So let's print around 2299. The 10 stays before. 2289. Oh, and that assertion needs to stop. Box overlaps wall. Okay. So this is where the carnage has been done. Here. Okay. And just before that, wait, what? There's no box overlapping a wall. Oh. Oh, it's already clipping into the wall here. So this is clipping into the wall from the other direction. Right, you have to check both directions. Great. Well, let's find where it clips in the other direction. By adding an assert. So in this case, assert boxes.map. We want to check the right side of the walls. So walls dot map east is empty. And I could swap these two. Now well, yeah, box is clipping the wall. And that happens at 2265. Okay. So we're gonna go 2255. Check that. Oh yes, stop the assertion. And print that. All right, what do we have here? This is where the carnage has been done. Okay. And a step before. Okay, so that is again with our north-south pushing connected components. So here, vertical. Well, in this case, this is right before it's about to happen, right? Yeah. So so no walls is lying here. So all the connecting boxes, we look in the direction we're moving, and we're looking east of the direction we're moving. We also have to look west for walls. Yeah. Yeah. Okay, we have to check 3 spots. We have to check that this is not a wall, this is not a wall. I don't know why I thought 2. There are 3 ways. Okay, okay. So I just changed this code from west to east. I actually have to check all 3. So walls n.e or walls n.west. I think that's it. What am I making? I'm making a solution to part 2 of admin code. Let's let this run. I think this will get us our answer. So we're on admin code 2024 day 15. And yeah, okay, just got the solution. So we have a bot that's walking around in a factory full of boxes and walls, and as it walks around, it pushes these stacks of boxes around. And I can show you a little animation. We're just going to take all of them so you can see what's happening. And basically, the goal of the problem was to prove that we could simulate this. And there we go. Ah. Oh, that took so long. This will be a good video for me to review about my debugging practices. Step 1, get sleep. Hooray, hooray. Thank you. Whoa. Okay, well, I mean, it halted. I don't know why, but we'll assume that's the end. um, let's look at the leaderboard. I'm still holding out at 8th. So anyone have any interesting approaches to today's problem? I mean, there's not much you can do, right? You just simulate it. Hold on, I want to check today's board. So that's 5th for, no, this is day 14, day 15. As 9th for part 1. And again with the big delta, 15th for part 2. Yeah, I dropped a lot of rank, but it seems like this is a tough one because 3 hours in, you don't even have 5,000. So I suppose people did struggle. All right, recursion for days. Yeah. So this can be a lot cleaner. This could be super clean, actually. Scala gives us tools for this. So when I start tomorrow, I want to start with a bit of a refactoring of this. Take out all these asserts, turn it back into a worksheet, yada yada, all that. So if any of you are early, I'm probably gonna show up about between 30 and an hour, 30 minutes and an hour early. But let's figure out who to raid. In the admin a code category, someone's doing C sharp. Oh, they've already finished. 1525. Wow, wait, 1525? You're not even. Are you even allowed to stream if you're that fast? Hold on, let's take a look. And Soggy Boy is working on day 15 in Go. Wait, what does 1525 mean? Oh, day 15 of 25. Those aren't ranks. Okay. They're still working on it. C sharp. I don't see a lot of C sharp. It seemed like maybe a cumbersome language to do this in. Yeah, let's tune in there. Um, Soggy Boy sounds familiar. Let's take a quick peek at the stream. Oh, they're just starting. Let's do this because they're just starting, and I'd like to see how they're approaching at least part one, right? No cumbersome than anything else, except maybe Elixir. Is it more cumbersome than Go? Is a question. Okay, let's see. Let's see Soggy Boy do it and Go. Australians, do they just like wake up? What time is it in Australia? Oh, JavaScript. No, I mean, I think JavaScript can be concise. It can be hard to work with, but it could be concise. There are plenty of I don't know. All right.